Hello Year 7s and welcome to our next lesson on fractions. Today we're going to be looking at mixed number. And a mixed number is, this image up here is probably going to help us as a quick introduction. It's when we have a whole number component with a fraction. So it's a mixed number. So we'll talk about that today. So a quick recap again on fractions. We've got 3/5 or 3 parts out of 5. 3 is our numerator and 5 is our denominator. Another quick recap for us, our proper and improper fractions. So a proper fraction is when the numerator is smaller than the denominator. So this is just a quick revision from our last lesson. An improper fraction is when the numerator is larger than the denominator. So this is just a quick recap from our last lesson. So improper fractions. So in this case here, we can actually see that they're actually pizzas that we've got shown there. And we've got 5/2, which we know is an improper fraction. So 5, and there are 5 parts, as we can see there, and each part is a half. So we've got 5 halves. So these are all half a pizza. So as an improper fraction, it's written as 5/2 or 5 halves. Or there's a way for us to understand that. Now, when we talk about a mixed number, this is something that I would like you to write in your books, because this is our next definition that's quite important. A mixed number is a whole number together with a proper fraction. It's another way of writing an improper fraction. So it's a really important definition. A mixed number has a whole number together with a proper fraction. Okay? And it's another way for us to write an improper fraction. So pause the screen and copy this definition down. You don't need to copy the pictures of the pizza. Okay, I'm going to continue. So if we have a look at what we have before, now we had 5 parts out of 5 halves, or 5/2, or 5/2 I should say. Now what I've actually done with the pictures is I've actually turned them around so that these 2 halves look like a whole pizza, these 2 halves look like a whole pizza, and then I've got a half on its own. It still is 5/2, so I've still got 5 halves, 1, 2, 3, 4, 5. But I can actually represent this as a mixed number and say 2 wholes. So I've got 2 whole pizzas and a half. Okay? So this is how we would convert 5/2 is 2.5 pizzas. Okay? If they're all half pizzas each. So here's another one here. We're going to change an improper fraction to a whole number. Now, these are pieces of pizza. In this first top half of my screen, I've got 10 thirds, okay? Each piece is a third in size. How many pieces do I actually have? I've got 10. So that is 10/3, because each part is a third in size. So I've got 10 parts that are a third in size. Now I can combine some of these thirds, as I have in the second part of this slide. And on the bottom part, you can see that 3 of these third pieces combine to make a 1 whole, because 3 thirds is the same as 3/3, and we know that 3 divided by 3 is 1. So I can combine 3 of them to make 1. I can combine another 3 of these pieces up here to make another 1. I can then combine another 3 to make another 1. And then I have 1/3 on its own. So 10/3 is the same as 3 and 1/3 as a mixed number, because 10 divided by 3 would be, the closest number to that would be 3, because 3 times 3 is 9, and then I've got 1 more left over, 1/3 left over. Okay? So we're going to go through a rule to help us understand this a little bit better. So the numerator of the improper fraction is 10. The denominator is 3. Now notice when I convert my improper fraction, which is 10/3, to my mixed number, the denominator remains the same. So that's really important for us to remember. The only part that's going to change is my numerator. I'm going to have 10 divided by 3. It will give me 3 wholes, and the remainder of the division is the numerator. So 10 divided by 3 is 3, and 1 remainder, so 1/3 is my remainder. So we have another one here, another example. This time we're going to change a mixed number to an improper fraction. So we're going the other way. So I've got 1 whole and 3/8. over here. That's why it's 1 3/8. Okay, so I've got one whole pizza and then another 3 pieces, each an eighth in size. So it's 1 3/8. So if I was now to separate these pieces, in this current setup it looks like I've got one whole, but I can separate all these pieces up as what I've done down here in the second half of the slide. And how many pieces do I have in total that are an eighth in size? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 pieces. Each one of those pieces is an eighth in size, and that's exactly the same. So this image down here is showing me the fraction as is up here, but we're just now showing it and converting it to an improper fraction. So what am I actually doing when I convert it to an improper fraction? I've got 1 3/8, okay? The way that we convert it is I've got 1 times my denominator, so 1 times 8 plus my numerator. Again, my denominator stays the same. When I'm converting a mixed number to an improper fraction, the denominator stays the same. I'm going to give you a few rules to help you with this, so you don't need to copy this. So example number 1, converting mixed numbers to improper fractions. So convert 3 1/5 to an improper fraction. So how do we go about doing this? Now, the colours are really important, and I would like you to copy this example into your book, and I would like you to use different colours. Pens, pencils, or texters, whatever, even if you highlight it, because it's going to help us explain what we're doing. So converting 3 1/5 to an improper fraction, what do? Well, I can see I've got my whole number is 3. I've got my 1 as my numerator and 5 as my denominator. Now I multiply my whole number, my 3, by my denominator, and you can see that the colours are matching, so we can see what happens. I then add the numerator, which is 1. So 3 times 5 is 15, plus 1 is 16, and that's how I get my new numerator for my improper fraction. My denominator remains the same all the way through. So 5 was my numerator, my denominator initially, it will stay as 5 here. So 16 over 5 is the same as 3 1/5. Okay? 16 over 5 is the same as 3 1/5. So if you copy this example, use the colours, and you'll be able to use the same procedure when you're converting a mixed number to an improper fraction. So pause and copy. My next example, I'm going to do another conversion of a mixed number. So 2 5/6 converted to an improper fraction. So again, it's the same idea. I've used the colours to try and help us see. And you'll notice if you have a look at your previous example, I've used the same colours and we're going to follow the same procedure. The most important thing is my improper fraction is going to have the same denominator. So 6 was my denominator in my mixed number. So that 6 is now going to be transferred straight across. The tricky part is trying to work out my numerator. And how do I do that? I multiply my whole number by my denominator, so 2 times 6. And it's in brackets, which means we need to do that component first. So it's 12 plus 5. 5 was my numerator, and that gives me 17. So 17 over 6 is the same as 2 5/6. Okay? So again, I want you to pause your screen and to copy this example into your book. And if you can use the same colour coding, it will help you understand what's happening. Okay, I'm going to move on. Example 3, converting improper fractions to mixed numbers. So now we're going to go the other way. My improper fraction here is 11 over 4, and I want to convert that to a mixed number. So I've used colours again just to try and help you understand what's going on. So I've got 11 over 4. Again, my denominator will always remain the same. You can see that I've got a 4, and a 4 stays here in my final answer when I convert it to a mixed number. What do? I have 11 divided by my numerator divided by my denominator. 11 divided by 4 is going to give me 2, because 2 times 4 is 8. Remainder, 3. Because 11 doesn't divide equally into 4. Okay, I have a remainder. So 11 divided by 4 will give me 2, because 2 times 4 is 8. And then I've got a remainder of 3. So notice the colour coordinations here again. I've done the colouring to help you. The 2 becomes my whole number, which comes out the front of my mixed number. The remainder is my new numerator. So again, I would like you to pause and copy this example. I would like you to use the colour coordinations that I've used so you can try and follow what I've done. So pause and copy. Okay, moving on. So again, I've got 23 over 7, and I want to convert this to a mixed number. Again, what's the process that I'm going to follow? Again, I divide my numerator into my denominator. So 23 divided by 7, it's 3, because 3 times 7 is 21. And I've got a remainder of 2. Okay, 3 times 7 is 21, remainder 2. So my whole number, my 3, becomes my whole number of my mixed number fraction. My remainder is now my numerator, and my denominator remains the same. I had a denominator of 7, it remains as a 7 for my mixed number fraction component. So pause the screen and copy this example into your workbooks, please. Use colour coordination to help. Example 5, writing mixed numbers in simplest form. So now it wants me to actually convert to a mixed number in simplest form. So what is the process that I'm going to do? So this is something I want you to copy. It's a two-step procedure. Step 1, we need to simplify the fraction. That's what I would do. So if you remember, simplifying fraction means that I divide my numerator and my denominator by the highest common factor of both of these numbers. In this case, I'm going to divide by 2, because 2 is the highest common factor of 20 and 6. So 20 divided by 2 is 10, 6 divided by 2 is 3. When we're simplifying, we must divide our numerator and our denominator by the same number. So now I've simplified my 20 over 6 is simplified to 10 over 3. That was step 1. Have I converted it to a mixed number? Not yet, so now that's my next step. Step 2 is to convert to a mixed number, and I'm going to follow the same process as we did before. I've even kept the same colours to try and help us remember what we're doing. Actually, follow the same colours on this particular slide. So 10 divided by 3, my numerator divided by my denominator equals 3. And I have a remainder of 1. So the 3 is my whole number, the remainder is my numerator, and my denominator remains the same. So it's 3 1/3. Another example here, I'm converting 18 over 4 to a mixed number in simplest form. So same as what I did in my previous example, this is something you can copy in your books. The first step is to simplify the fraction. So what's my highest common factor of 18 and 4? It's, in this case, we're going to use 2, because 2 is the highest common factor. So 18 divided by 2 is 9. 4 divided by 2 is 2. So when I'm simplifying fractions, don't forget, I must divide my numerator and my denominator by the same number. In this case, it's 2. Step 2, convert to mixed number. So now I want to convert my 9 over 2 into a mixed number. So what am I going to do? Okay, same thing here. I've divided my numerator into my denominator. So 9 divided by 2 is 4, remainder 1. Because 4 times 2 is 8, plus 1 is 9. So 9 divided by 2 is 4, remainder 1. The 4 becomes my whole number out the front. My remainder is my numerator, and my denominator remains the same as 2. So you can see that whenever we've converted to a mixed number, my fraction must always be, my fraction component must always be a proper fraction. If you're converting to a mixed number and your numerator is not smaller than your denominator in your mixed number conversion, you've got an error. So that's something for you to keep in mind. So please pause and copy this example into your books. Okay, moving on. So the questions that we're going to be doing for this particular exercise will be specified in the lesson log. So please read the lesson log and you'll know which questions and exercises you need to do. Thank you.